Tommy. I'm from Greenhope, Indonesia. You can check our website as greenhope.co. And then we are just introducing you a couple of technologies we have. One is the Axiom, which is the OXO biodegradable plastic technology, where basically what it is when you add it to, you substitute a certain percentage, a small percentage to regular plastic, you will make the plastic to be able to degrade. Not fragment, physical fragment, but degrade. What it degrades is the molecular and chemical inside of the plastic. The hydrocarbon chain got cut off, and that makes it, the microbes can eat it. So it makes it OXO biodegradable within a period of around 2 years, and stimulated by sunlight, by UV, by mechanical pressure. So it's a very economically viable solution for usually mass market products, middle and lower price of the market.
So Tommy, you're saying that basically we only need to add about 3% of this product into our master batch in order to achieve this biodegradable or break up this molecular chain, just 3%.
Yeah.
And by how much would that affect the cost of our final product, approximately?
The cost based on the Indonesian experience, it's around maybe 3% increase, so less than 5% absolutely. And we are in Indonesia, we're a market leader. 99% of the modern market in Indonesia use also biodegradable bags, and we are leading the market with 60% of the market. And yes, it is only 3%, and it's a simple concept actually. Plastic is basically a very long, polymer is a very long molecular chain. The reason that it doesn't biodegrade is because the microbes cannot eat it. It's too long. So the faster you can chop off all those molecular chain, the more it's be able to be biodegradable. So we've been in the market for 7+ years, and we have never had problems in our products, and it's just been proven. The international standards on this is, you can check, it's ASTM 6954 that proves that it goes through the oxidation and biodegradation of these plastic bags.
And what is the availability of your product, OXIUM, yeah? OXIUM, what's the availability?
In what
terms
sense?
of, would you be shipping from Indonesia?
We can ship either the master batch, we can ship the additive, we call it,
The additive,
or we can
yeah.
ship the end products, whichever that your country needs and can really solve the problem.
Okay.
I can tell you, the whole world is trying to figure out what is the next generation solution of plastic.
Yeah.
And each country has to learn from each other, but learn from the best practice. And there won't be any single answer that's appropriate for the entire world. It all depends on the climate, depends on the local culture, depends on the local economic level. You know, Americans with their $7 McDonald's meal can afford 50 cents packaging.
Yeah.
In Indonesia, our nasi goreng fried rice is 70 cents. We cannot afford 50 cents packaging. It has to be cheaper, but equally effective.
And your additive is applicable for all these types of packaging, am I correct? For polystyrene?
Yes, polystyrene. Basically, the concept is that any types of plastics and the disposable one, the ones that is short useful life, we can make it degrade by design between 2 to 5 years, which is good enough for most cases, rather than 500 to 1,000 years. And the plastic problem is too complicated to be tackled by one solution technology alone. So we're always campaigning for 4 approach, which is what we call 4R. We need to reduce usage, we need to reuse plastics that we can, and we need to recycle where we can. And once you recycle a few times, because plastic always downcycle, at the end of life, we need to return it back to Earth. So 4R. That's all important. So the government needs to orchestrate this 4R to happen and not favor one technology over the other and stuff, because it can be in a danger of, for instance, it could be taxing the poor. If you force a bioplastic that is more expensive, for instance, you can end up taxing the poor if you don't have the you don't have the right alternatives.
Yeah.
And we have EcoPlus, which is another technology of ours, which is...
Can you tell us a little bit about EcoPlus?
Sure. Yeah, hello. So EcoPlus is our bio-based, cassava-based bioplastics. So what it is this, from the cassava starch, this is the plant. Yeah, usually south of equator are very good producers of cassava. Yeah, in Indonesia it grows abundantly. I know in Africa it does, South America as well, India. So from cassava starch we can polymerize it into a resins. So from these resins, cassava base, you can blow it into all these various nice bags. It's really...
Wow, this is even printed.
Yeah, and printed and everything. And it's already a real product because this tissue and everything we use
Yeah.
Yeah, so this is an example of the film, and it's good. It's waterproof and everything. The only thing about bioplastic everywhere in the world right now, we're not ready yet for mass market, middle and lower level of economic strata because it's still somewhat more expensive. So our cassava EcoPlus, for instance, we're talking around about 50% more expensive than regular plastics, up to a double. So that's a double, which is already, I know, I can assure you, one of the most competitive bioplastics out there. Compared to some of the other types, corn-based and everything can be 3 times, 5 times. Ours is, at most, is double. But still, not everybody can pay that, particularly the mass market.
Well, in time, hopefully once it's scaled up, then the cost can come down.
Yeah, absolutely. So it's just a matter of what is fit for purpose right now and make sure that we have the right standards to prove that it's according to the claim, but then we can use it.
All right, Tommy, thank you very much, bro.
Thank you so much.
Good what you do for the planet, dude.
Thank you. Together we can.